I'm here today with two of my favorite scientists. I have, you want to introduce your name?
Bill.
This is Bill. You want to tell Mr. Lee hi?
Hi.
And this is Milena. Milena, do you want to tell Dr. Lee hi?
Hi.
All right, and today we're going to talk about chemical reactions, okay? So let me ask you this. Have you guys ever wanted to make your own toys?
Yes.
Would that be cool?
Yeah.
So I have some things today. What do you think if we were to, I don't know, make some Legos or some jewelry?
Yeah.
You think that would be fun?
Yeah.
Okay, and you guys could actually switch off if you wanted to. We can make some different things. In fact, if you want to take a look, yeah, it's got designs in it. Isn't that cool?
Yeah.
So one of the things I thought would be really cool is if you could see what we're going to make ahead of time, and then I can tell you a little bit about the science behind it. So if you take a look, I made you a dinosaur and like a little shape, and I made you a dog and a little flower. Now, that is plastic. We're going to make plastic out of milk. I know, crazy, right? That's a good question. We're going to talk about that here in just a little bit. So take it real gentle because they're still drying and tap them. They're going to be hard.
This one's the hard one and this one's the soft.
Yeah, because some of them are still drying. And so what's going to happen is we're going to make those things today, and then you guys are going to be able to paint them and decorate them once they're dry. Does that sound cool?
Yeah.
All right, but first let's talk about some science stuff, all right? So I'm going to say some big words today, but I'm going to break it down so that they're going to be really easy to understand, and you guys are going to have them in your heads forever. You guys ready?
Yes.
Okay, so the first thing I have to ask you is, what is the smallest, teeniest, tiniest thing you could ever think about seeing?
A germ.
A germ. And you can't really
Dust.
see it. Dust, right? Well, did you know there's something even smaller than that? It's something called an atom. And everything in the world is made up of these little atoms, okay? And so there are atoms all over the world in all kinds of different things, but atoms are part of matter. And matter is anything that has mass and takes up space. So let's look around this room and let's talk about some things that have some weight or some mass and take up space. So, Bill, can you tell me something? What do you think in this room?
A couch.
A couch is a great one. How about you, Milena?
A dog.
A dog is definitely matter. It takes up space and it has mass. Give me something else, Mr. Bill.
A TV.
A TV is a great example. What about you, Milena?
A plate.
A plate is definitely matter and takes up space. What about
The
you?
table.
The table is another one.
And us.
And you, that's right, absolutely. You guys are matter because you take up space and you have mass, okay? So pretty easy, right?
Mm-hmm.
So everything in the world is made up of atoms, which makes up matter, right? Now we're gonna get a little bit bigger, okay? So if I were to talk about something that makes you a part of you, I would talk about something called a monomer, okay? Now, a monomer is just a small unit. Now, this would be like if we magnified it, made it great, great big, because you can't really see a monomer. It's like an atom. It's tiny, okay? But if I were to make this really, really big, one unit would be called a monomer. And monomer means one. Monomer means one, okay? So, if I were to take more than one monomer and I hook them together with other monomers, some are the same, some are different, I get what's called a polymer. And polymers, a polymer means many. So you had a monomer, one, mer means part, hooking together to make a polymer, which means many. Now the cool thing about polymers is this. Sometimes the chain is rigid, it doesn't move. Sometimes it's super flexible and it will bend. Sometimes break, right? Oops. It will bend, and that's what everything is made out of. So let me ask you this. Do you think something hard is a rigid polymer? Something that doesn't move?
Yes.
Yes. And what about something soft? Something that would give? Is that a flexible polymer?
Oh, yes.
Yeah, because look, it bends, right? Good job. All right, so now that we've talked about atoms, we've talked about matter, we've talked about a monomer, and we talked about how more than one monomer is a polymer. You guys are so smart, good job. Now we're going to talk about something that makes them. Because I don't know about you, but I don't think things are just big long chains, right? We have to make them into something, right? So what?
Chemical reaction.
Yeah, you're already ahead of me. You're smart, Bill. So we're going to talk about chemical reactions, some chemical changes. So let me talk to you a little bit about it. So I've got it up here, okay? So a chemical change is a change that results in a brand new substance, okay? And it also, the change cannot be undone. So for example, some ways that you can have a chemical reaction are through burning. So think about a match, or think about a log in a fire. If I burned it up, can I undo that and make it a log again?
No.
I can't, can I? So that means that a chemical change has occurred, okay? What about a rusty nail? Can I unrust a nail?
No.
I can shave some of the rust off, but I can't change it, can I? It's already rusted, so it can't be undone. What about cooking? Cooking is an example of a chemical change. If I cook something, if I cooked meatloaf, can I uncook meatloaf?
No.
It doesn't work, does it? Or what about frying something? If I took an egg and I fried it, can I unfry that egg?
No.
No. So a chemical reaction changes the substance, right? Because a fried egg in an eggshell would become a fried egg you could eat. And they don't look the same, do they? If I took a piece of wood and I burned it, I changed it forever. I can't undo it, can I? So it's a new substance and it can't be undone. Now, some ways that you can tell that a chemical reaction has happened is the odor. Sometimes it's stinky, like stinky socks. Sometimes it's because the color has changed. So think about something that might have changed color if it was burned. Yeah.
A log.
A log, okay, yeah.
A drink.
Okay, so if a log or a drink were burned, what would happen? What color would it be instead? So if the log was brown before, what color would it be now? Black, or it could be even ash, right? Like nothing, maybe even a gray. If I burned up a drink, would you still have water in your drink, in your glass?
No.
The water would be gone. Can't undo that, can we? Okay, so a chemical reaction has changed. And the other way we can tell is that it gives off heat. Sometimes it's hot. So ways we know that a chemical reaction has happened, it sometimes smells. It could be a good smell, but it's usually a stinky smell. Color, the color has changed like a log that's been burned, okay? And then heat, it gives off heat, okay? So now there's two different kinds of chemical reactions. Endothermic and exothermic. Those sound like big words, don't they?
Yeah.
Should we break them down a little bit?
Yeah.
Okay, so an endothermic reaction is something that absorbs heat. It sucks it in, like when you're cooking. A pan sucks up all of the heat and it transfers it to the thing that you're cooking, okay? So imagine that you're cooking a hamburger in a pan. That chemical reaction has occurred, and we know that because of the odor. Is hamburger stinky? No, but it smells good when it's cooked, right? Has the color of the meat changed from pink to brown once it's cooked?
Oh, yeah.
Yeah. What about heat? Is it hot now? Or is it still cold like the pink hamburger?
Cold.
So if you make a hamburger out of pink meat and you put it into a pan and you cook it and it's all the way done, is it hot or is it cold?
Hot.
Hot, right? Absolutely. So we know it's changed because it smells good, it's changed color, and now it's hot. So we know that that's changed, okay? All right. The other type of reaction is called an exothermic reaction, and that means outside. Heat is released. So like if you were to strike a match at a campfire, and you like to go camping, right? So you go camping and you strike a match, that's an exothermic reaction because the heat is released. It's out in the open, okay? So the next time you go camping with your dad and your brother and the rest of your family, you can help start the campfire, because I know you've had lots of experience with that, right? So you can tell them you're going to start an exothermic reaction and see what they say. What do you think?
Yeah.
I think so too. All right. So one of the things that we're going to talk about next is I'm going to have you watch a video on polymers, and then we're going to do our activity. Do you guys have any questions about what we covered so far? And as we go along, if you have other questions, just let me know, okay? And you might not have them until we start our activity, and that's fine too, okay? So let's watch a little video on polymers.
The word polymer literally means many parts. But a polymer isn't a specific thing. It's anything, usually a molecule or material, made of smaller repeating bits, monomers. So, polymers are large molecules formed by linking together smaller repeating units called monomers. Many people think of plastics when they hear the word polymer, but polymers can be synthetic or natural. DNA, proteins that make up our hair and muscles, and cellulose, the molecule that gives plants their sturdy structure, are all natural examples of polymers. Like all molecules, polymers can have different shapes and sizes, so the properties of a polymeric material will depend on which atoms and molecules it contains and how they're connected. Some polymers are rigid and strong, while others are flexible. And researchers are constantly looking for new ways to create even better polymers with useful properties. Some scientists study spiders for clues because their silk polymers are famously strong yet flexible. Others are working on ways to control polymer assembly. This will allow them to create new kinds of materials that are easier to recycle, can fix themselves after they're damaged, or even respond when exposed to light or electricity. From muscle fibers to plastics, polymers are useful materials that we rely on every day. Understanding how to build them from different types of monomers will allow researchers to design and build a more flexible future, bit by bit.
Okay, so what did you guys think of that video? Did you guys realize that you're made out of polymers?
Yeah.
That's kind of cool, isn't it? Pretty neat. All right, so lots of different things can be made out of polymers, right? Good job. Okay, so in just a minute we're gonna go in the kitchen and we're gonna make something cool. We are going to make plastic out of milk. Now, I know you guys have that look on your face, like, what are you talking about? You're crazy. But we know that milk is made of polymers. So what we're gonna do is we're gonna help break those polymers down through a chemical reaction using heat to cook the milk, okay? And then I've got some questions for you as we go along, okay? So you guys ready to get started? All right, let's go.